Problem 2. A particle moves along a straight line. For time between 0 and 5, the velocity of the particle is given by v of t equals negative 2 plus the quantity t squared plus 3t raised to the 6/5 power minus t cubed, and the position of the particle is given by s of t. It is known that s of 0 is equal to 10. Part A, find all values of t in the interval from 2 to 4 for which the speed of the particle is equal to 2. Well, hopefully you remember that speed is equal to the absolute value of the velocity. So we need to find out where does the absolute value of the velocity equal to. So the absolute value of the velocity is the absolute value of negative 2 plus t squared plus 3t, 6/5 power minus t cubed. So that's the speed. We would like to find out where does that equal to. All right, please keep in mind that we are allowed to use our calculator. So from here, I like to set it equal to 0, so I can use the 0 feature of my calculator. So I'm going to have the absolute value of negative 2 plus t squared plus 3t to the 6/5 power minus t cubed minus 2 is equal to 0. And then from here, we're going to actually graph this on our calculator. And then we're going to use the 0 feature of the calculator to help us find the answer. And when we do that, there are actually two places where the graph equals 0, and that's going to be at t equals 3.128, and it's also going to be at 3.473. All right, and from here, just make sure when you set your window should be between have your x min be 2 and have your x max be 4, and that will help you out when you do that. All right, so when we found out, said find all values of t for which the speed is equal to 2, I found the value. So those are the two right there. That was worth 2 points. If you have this right here, you could either have that or you could have the absolute value of v of t equaling 2. Either one of those was worth a point. And then if you're actually able to get the answer, both answers, you're able to get another point. So this part was worth 2 points. Okay, part B. Write an expression involving an integral that gives the position s of t. Use this expression to find the position of the particle at time t equals 5. All right, so we need the position of the particle. Okay, to get the position, we know that you start at 10. So I'm going to start at 10, just like in that processing problem we had 500 tons of unprocessed gravel to start with, same type of deal. And then I'm going to add how much the integral is going to move. So the position, we know to get from position to velocity to position, we will take the integral. So I'm going to take the integral from 0. I don't know how far it's going to be because it just says from any time t. So I'm just going to go 0 to t. And then once again, same thing, since I already used a t here, I can't put v of t again. I've got to use a different variable. So I'm going to put v of x dx. So this would be my integral expression. All right, and then it said to use this expression to find the position of the particle at time t equals 5. So now all we need to do to find s of 5, we're just going to plug 5 in for our t. So 0 to 5, v of x dx, and we'll actually use that formula right there. From here we can do some math 9 action, and when we do that we're going to get negative 9.207. Right? If you properly found a formula for s of t, that would be worth a point. And then if you actually were able to find s of 5, that would be worth another point. It would be possible on this one. It would actually be a little bit complicated to take this integral, so I guess I wouldn't suggest it. There are some different ways that we could get the answer. If you did yours a different way, you might want to ask about it and see if that was acceptable. So this was worth 2 points. All right, part C. Find all times t in the interval from 0 to 5 at which the particle changes direction. Justify your answer. Okay, if I know the particle changes direction, the velocity will change signs. So what I need to do is figure out, I'm going to make myself a velocity chart. Okay, if I'm going to figure out a velocity chart, I first of all need to figure out where does that velocity equal 0. And here's my velocity formula right here. So to figure out where the velocity equals 0, we will go ahead, we're going to graph the velocity, and then we're going to use the 0 feature of our calculator. This time we'll have our x min be 0, and we'll have our x max be 5. So we only want values between 0 and 5. And if I use the 0 feature of my calculator, I'm going to get t equals excuse me, 0.536, and I will also get t equals 3.318. So if I do that, I'm going to get 0.536. 0.536 right here, and I'll get 3.318. All right, now there are two ways that you can do this. You can either plug, let's say we could plug 0 into the velocity formula and see if we get a positive or negative answer, or we can actually use our graph, and we'll notice that our graph is below the x-axis before negative 0.536. It's above the x-axis between 0.536 and 3.318, so this is going to be a positive, and the velocity graph is below the x-axis after that, so my velocity will be negative. So I have a velocity chart, and now I just want to know, where does the velocity change direction? So I'm going to say, not the velocity, the particle. So I will say the particle changes direction at t equals 0.536 and t equals 3.318, and I can say that it changes at both of those because at both of those spots the velocity changes sign, and I will say because the velocity changes sign. Okay, we do need to check it because it is possible that this could be plus and plus, which would mean the particle does not change direction at that spot. All right, this problem was worth 3 points. If you, somewhere on your paper, set the velocity equal to 0, whether you actually put v equals 0 or you put the formula equals 0, that was worth a point just for doing that. If you're able to get the two answers of 0.536 and 3.318, you got another point. And then if you were able to say that it was because the velocity changes sign, that would be worth your 3rd point for this problem. Okay, part D. Is the speed of the particle increasing or decreasing at time t equals 4? Give a reason for your answer. Okay, we've done several like these before. We know the speed of the particle. We need to deal with the velocity at 4, and we need to deal with the acceleration at 4. Okay, and we'll know if they have the same sign, the speed will increase. If they have different signs, the speed will decrease. So velocity at 4, all we need to do is simply plug in 4 in for the t in the velocity equation, and when we do that, we are going to get negative 11.476. All right, to get the acceleration at 4, that's going to be the derivative of the velocity at 4, and remember, if it's a calculator problem, you should never have to take the derivative by hand, so we're going to let our calculator, we're going to use some Math 8 for this one, and if I do Math 8 to find the derivative of this at 4, I will end up getting negative 22.296. Okay, for both of those I did get 2 negative answers, so I'm going to say the speed of the particle is increasing, and that's because v of 4 and a of 4 are the same sign at t equals 4. All right, and that's pretty much all we have to say on that one. So this was worth 2 points. If we came up with a conclusion that the particle is increasing, the speed of the particle is increasing, we'd get a point. And then if we said why, we'd get a point. So that was worth 2 points again.